In this video, we're going to be looking at how to convert between mass and moles and representative particles, whether those are atoms or molecules or formula units for an ionic compound. Our first question says, I have 4.7 grams of potassium and I want to know how many moles that is. So the first thing that we want to do is take our 4.7 grams for potassium and put that out front. Now, when we're going between mass and moles, we're going to use the molar mass. And remember, when you're doing unit analysis, whichever unit you start with has to go on the bottom so that it cancels out. So in this case, I have grams on the top, so I need to put my molar mass, the grams on the bottom, and the 1 mole on the top. So my units of grams cancel out, and I'm left with units of moles. So the molar mass for potassium is 39.0983 grams per mole. So now 4.7 times 1 divided by 39.0983 gives me 0.12, and the units that I'm left with is moles. In this next problem, I want to know 15 grams of gold is how many atoms. So in this case, I need to go all the way from grams to representative particles. So I need to do 2 different steps to get to my final answer. The first one to get me to moles, and the second one to get me from moles to atoms. So again, the number that I start with is going to go out front. I have 15 grams of gold. I need to convert that to moles using the molar mass. Since I started with grams, the units of grams need to go on the bottom so that grams cancel out. And at this point, I would have moles. But I'm not looking for moles, I'm looking for atoms. And I know that 1 mole is 6.022 times 10 to the 23rd atoms for any substance. So since I had units of moles on the top, the mole has to go on the bottom to cancel out, and I'm left with units of atoms on the top, which is what I'm looking for. Then we multiply everything on the top, divide by everything on the bottom, and I get that 15 grams of gold is 4.586 times 10 to the 26th atoms. This next one is a little bit different. So it takes it a step beyond what we did last year. Here it says a packet of an artificial sweetener contains 40 milligrams of saccharin, which has a molecular formula of C7H5NO3S. Given that saccharin has a molar mass of 183.18 grams per mole, how many carbon atoms are in this packet? So this isn't really more difficult, we just need to think about the process it is that we're doing. You can't just plug it into that little roadmap because it doesn't give us all of the steps we need. When we have the molar mass, that's the mass of 1 mole in grams. But we don't have grams, we have milligrams. So the first thing we need to do is we have 40 milligrams of saccharin. I need to convert that to grams. So you should have the prefix milli memorized, and there's 1 gram is 1,000 milligrams. So now the units of milligrams cancel out, and I have how many grams of saccharin I have. Now from here, I can do what we've done before and say that 1 mole of saccharin has a mass of 183.18 grams. So unit of grams on the top cancels with units of grams on the bottom, and I have moles. But we need to read very carefully. This says how many carbon atoms are in this packet. So I need to convert from moles of saccharin to moles of carbon. Well, if I look at the subscript, there are 7 moles of carbon, C7, for every 1 mole of saccharin. So my moles of saccharin cancel out, and I now have how many moles of carbon. But I don't want moles of carbon, I want carbon atoms. So now we're going to do the moles of carbon atoms on the bottom, moles of carbon on the top, and I'm left with 6.022 times 10 to the 23rd carbon atoms on the top. And when I multiply that out, I get 9.20 times 10 to the 20th atoms of carbon.